multiplying vectors. Here I have 1/2 times vector A plus vector B minus 2c. So first thing we want to do is we have this vector A, it has a magnitude of 40 newtons. We're going to move it into place and we're going to multiply it by 1/2. So we'll get something to measure with, and we know that this measures approximately 4 centimeters because we drew this to scale and each centimeter represented 10 newtons. So what I'm going to do is I'm going to draw another vector that's half as long as A. And try to get that as precise as I can. Let's move this a little bit out of the way. Okay, so that's pretty close. So we'll go ahead and color it again red to represent 1/2 of A. Okay, so that is 1/2 of A. So we're going to move the A out of the way. We're done with that vector here. And we'll move what we're using to measure out of the way too. We'll put it up here. So now we're going to do 1/2 plus B. Now I'm going to give myself plenty of space. I'll move this down to here. We'll bring the B in. Again, notice I do exactly what I did before when adding. I have head to tail. Head to tail right at this end. Now we want to take C vector, we'll move it into place, but we can't just add it directly because it says minus 2c. So what we're going to do is we'll bring this down and we measure this, and again this should measure 4.5 because we have 45 newtons here. We'll bring that down and we see, yeah, it does. So now we're going to draw a vector that has a length of 9, but the arrowhead needs to go back the other way. So I'm just going to start out, we'll draw a vector 9. We're going to draw it exactly parallel if we can, as precise as we can. Okay, that's pretty close. So that vector here, we'll color it blue. I'll move this back out of the way. This new vector here represents minus 2 times C. I've doubled the length of the original vector C, and then since it's negative, the arrowhead has to go back the other direction. So now we'll just drop this vector into place. Again, notice how I do this, head to tail. Then the resultant vector would be from the tail here to the head here. And that would be my magnitude. Again, we'll color it orange like we did on the previous videos. And we'll give it twice the thickness. And that's the resultant. Now, again, we could just come down here graphically and measure what the magnitude of this vector would be. And notice we got something pretty close to 11.1, 11.2. So that would represent like 111 or 112 newtons. And that would be the magnitude of that vector. Now if I wanted to get the direction, all I'd have to do is drop in a protractor. I could bring this into place. And we would note that this vector from the positive x-axis has an orientation of about 171 degrees. So that there we have the magnitude being around 111, 112 newtons with an angle of 171 degrees. So that gives it what we need for the definition of vector magnitude and direction.